Welcome back. I'm here now with my dear colleague Nadine, my former colleague.
Yes.
Like I said before, we work together at Formlabs, and I'm happy to have her here today to interview her a bit about sustainability and 3D printing.
Mm-hmm.
So just introduce yourself to
Okay.
our wonderful, what is it?
Crowd?
Crowd. And then we'll go from there.
Okay, sure. So, hi. So, I'm Nadine Moises. I was born in Cordoba, Argentina. And since I was a child, I was always concerned about what could I do for the environment. And at home, I have a big garden, so I used to spend the entire day out there. And it got me very in contact with nature, and I also had a lot of pets. So I was always in the subject, and that really marked my path basically. And when I had to choose what to study in university, I thought, okay, I want to study something that will allow me to improve the products that we have nowadays in the world. I was always very concerned about the amount of waste that we produce, about where do we get our energy sources from, and how can we make that more in peace with nature. And that's when I decided to study industrial design. I studied there for around 6 years, and also my final thesis was about an energy generator that not only generates enough energy for a house, but also doesn't interfere with the environment.
Okay, I didn't know that.
Yeah. And after I finished studying, I decided to move to Berlin. Berlin is a city that I find very interesting. There's always a lot happening, and regarding technology, it's more at the forefront of sustainability, together with other cities of Europe. And I also had my sister living here, so that's why I decided to come here, study the language, learn German, and see which possibilities I could find here. And I found Formlabs 3 years ago already. And I was always interested in 3D printing. I think additive manufacturing is the future, basically, for every industry. I also needed a job, so
that's a bonus. It's a combination, right?
Yes. So yes, I applied and I started working there as a 3D print production assistant, and now I'm 3D print production consultant. And basically my day-to-day work is to assist our sales agents and also customers, and to see which material we can apply into every specific customer need, and how to adapt their production or their needs or their ideas to all the materials that we have. More than 25 materials at the moment in both technologies that we develop. So it's very exciting, and it also allows me to fulfill my goal to promote additive manufacturing in any industry, from medical to proper industrial production. So yes, that's a little bit about me.
Yeah, it's super interesting. Also, that about your thesis about the energy saving, right, in the houses.
Yeah, generating
energy. Yeah.
Yes.
So, what did you come up with, basically? What was the result?
It was an energy generator that I modeled basically and designed. In Argentina, specifically in my region, we have a lot of rivers with a very very fast rivers, and also a lot of people live around rivers. I don't remember the statistic at the moment, but you see a lot of houses and very small houses. And these rivers, they have a lot of energy, but it's very difficult to build a proper dam, or also the state energy cabling don't reach there. so I thought it was a perfect opportunity to generate something for these little houses with people who have between low and medium income. Solar panels would also be a solution for this case, but they are it's a very expensive technology for the country. It has been getting cheaper with the years, but either way, it's still a big investment. So what I designed was like, the concept was basically a floater with a small engine inside, and underneath in the water you would have 3 pallets that would turn with the stream of the river. And therefore, these pallets are also designed for the fishes and all the small branches to go through them and not to get stuck in them. So it was, you can just have it there like floating. And whenever we have very big tides, it's not a tide, like the river increases its flow very fast, in summer specifically. But we have a very good alarming system, so whenever the flood, that was the word, comes, this machine would send the user a sign and say, hey, so the user would have enough time to either take it out of the river, or if the user doesn't have enough time, the pallets would stop conducting energy to the engine. So if the pallets would break, they would be able to be replaced, but the engine would stay intact.
Wow.
Yeah.
Did you build it as well?
I built it, but not with the proper engine because it was very expensive for me to afford it. But yes, I tested in a river and the pallets were like turning. It was like very exciting to do.
Oh, really cool, yeah. Did you use 3D printing actually with it?
I did. I used 3D printing for the scaled models because the final model was something quite big, like 80 centimeters tall. So we don't have a 3D printer that large. So, but the small models, the scaled models, to do all the other type of like checks that I had to do, I printed them, with FDM at the moment.
Oh, okay. So you made like little models.
Yes.
So you can showcase basically what you wanted to do.
Yes.
In the end,
I also wanted to check because these models were modular, so how they could connect with each other, and all of those type of checks, I did them with 3D printing.
Really cool.
Yes.
3D printing already kind of influenced your world already.
Yes, and for the education, it's vital. I think it's vital piece of making people more aware of what can actually be done. Yes.
Yeah. Super cool. Thank you for the introduction. It was already very enlightening where you started with your journey. I'm just gonna go look at the question again. Okay, so you kind of covered how you got into sustainability. How did you get, we know now that you also got into 3D printing already in your studies, and how did you start using sustainability at Formlabs, at the company that we both worked at? How did you get into that subject? Like, who influenced you there, or how did that topic arise?
Well, we are a hardware company, so there's always some waste generated. So that's what I'm partly focusing on how to reduce this amount of waste. And I didn't have any specific influence. I'm like, nowadays I'm pursuing a sustainability management master, and with those tools, what I would like to focus more like in the future is how to make companies that either produce hardware products or software, how can they be more sustainable, and this transition that it's lacking, because you have a lot of systems that are already installed that they are very difficult to change, and that's something important to know. And with the background of industrial design, I got also like that tool to say, okay, it's not just saying now we're changing to another plastic that it's more sustainable, it's also changing a full chain of production. And that's what I want to focus on. and what I've been doing in the company is more operational work regarding what can we do better in our offices. And yes, in the headquarters in the US, we have for some years now an IPA recycler, and also in Ohio, where we produce our samples, we have another IPA recycler there. And I'm also working with ops basically there to see what can we improve.
Yeah, so kind of like ops is kind of like a facility management.
Yes.
They check kind of like a Hausmeister combined with
yeah, it's
just checking like organizational
to manage big offices.
Yeah.
Yes.
Yeah, it's cool that you've like kind of incorporated what you worked on before. Also, like your interest in sustainability into the job that you're doing right now.
Yes, like one of my goals is to promote this specifically. Throughout my thesis, for example, I wasted so much material subtracting it to make this big model, and whereas with 3D printing you just build it and that's it, and that's the material that you use, and therefore you wouldn't have any waste. And that's a step that you need to do whenever you're producing a physical product. And there's no way around it. The softwares nowadays, they have helped a lot to do a lot of checkings and mechanical testings, but either way you do need the physical product as a prototype to check a bunch of other things that you cannot check with the software. How it feels with your skin, how it feels when you touch it, is it too like rough or not? And you find a lot of problems once you print something or when you have the model that you couldn't see in the software. So it's a step that we cannot avoid at the moment. Maybe in the future with VR, maybe, but nowadays it's unavoidable, and therefore 3D printing is the key for prototyping and also decreasing times, which is also making the product life cycle more sustainable, right? If you spend less time sanding down a model and it only takes one day to print a model instead of weeks of production for one model that then you say, no, this is not working, it cuts costs. Very large costs, yes.
So if you kind of need like a physical model to actually see how the scale is and see if it actually works. You cannot just have it digitally.
No, and then launch a production, it wouldn't be smart to do.
No, for sure. Okay, I'm just going to take the next question. We go down. Can we talk about 3D printing and sustainability combined?
Well, what I can say about 3D printing itself is like the first thing that comes up with why 3D printing is more sustainable than traditional manufacturing. It's because it's additive manufacturing and not subtractive. That's something that's been going on since 3D printing started, so we already know that. But also cutting times. That's vital. Something also important to mention is nowadays in such a globalized world, it doesn't make so much sense to have your production in one site and then distribute it from there to the rest of the world. It makes more sense to have it regionalized because also you can adapt it to the country or region's necessities. For example, it's not the same to validate a product for the EU than for the US or for Latin America. And
because you need it worldwide, otherwise you need the kind of FDA approval or all those approvals that are the EU regulations, so you can actually sell your material
in certain regions. Exactly. So now it makes more sense also with logistic costs that we know that there's always like a logistic problem, either a big ship gets stuck somewhere or shipping gets even more expensive, to have production regionalized, and that's something that 3D printing can allow. Also together with, you can use one printer as a module, and you can increase this amount of modules as your production increases, or decrease them as you produce less. You can also change the materials within these printer modules, and therefore you have a very flexible way of producing something, instead of having a set like mold that will print, maybe will print 10,000 parts, but maybe you don't sell them. And that's also something that can be reduced with 3D printing. You print on demand, or you print per small batches, and you don't need to launch a full injection molding production just to make one simple product that maybe next season is not in trend anymore.
Not requested anymore.
Or maybe it's a failed product. I mean, of course, we have very successful products, and also we have products that don't fit into the market. That has always happened, and it will keep happening.
So it's more like the changeability of the market. You can adapt much quicker. You don't rely on the production of like outsourced logistics. Like you get materials from China and they get stuck. They get stuck because of Corona. No ship leaves the harbor, and then you're without the material that you need for production. Like I just had with the kitchen island that we're waiting for since forever. And there's only one part missing, but if that one part is not there, then you cannot produce the rest, and then you're waiting for a year to get something.
Something interesting to note there, I think COVID, I'm not going to name COVID, I'm just going to say the past few years have taught us that we have to be flexible and be able to adapt to something that changes overnight. So that's something that can be unlocked with additive manufacturing in general. Like nowadays, the technology has improved so much that you can print anything, even parts that you can then put in contact with your skin, or to make a surgery, you can have them in contact with the human body, and they will reduce the time that this patient will be in surgery, which that's life-saving. Or, as it had happened before, you can print millions of swabs because the need for them, it's like from one day to the other increased like 1,000%. You can also I was also watching a video yesterday actually about this diving mask from Decathlon, that they were transformed thanks to a 3D printed adapter to a oxygen mask for patients in hospitals. And this has been life-saving for so many people, and that was only available because of 3D printing. In 1 week they could design it, like have the idea on Sunday night literally, and on Thursday already have a final testing with some patients and see, hey, this is actually filtering the air and providing enough oxygen for patients to be able to breathe better while they were infected with corona. And things like that, as the population increases, will happen again, and have been happening throughout history. So it's not like it's never going to happen again. Maybe something else will happen, and that's where 3D printing really proves its value.
For sure, and then if you combine it then with sustainability, that's even better. Where you can change the material maybe. So that's our next topic, right? The what kind of materials are there that you could use in 3D printing that are also a bit more sustainable than the general resin that we use, or the general plastic material. What kind of materials are out there, and are there any in development, and do you see any trends maybe that you've come across in your research?
Well, trends, there are several of them. For example, in the medical industry, the trend will always go towards replacing titanium. So replacing a material that is capable of being inside the human body for years, like 20 years, 30 years. The trend will go towards that as a material development, right? As in development, I'm not allowed to talk about it, but there's always things happening. There's a lot of investment in that aspect of the company, in that area. So there's always interesting things coming up.
Are there any developments outside of Formlabs that you've come across?
Yes, so there is a company that it's called Anycubic, and they do have a plant-based resin. I haven't printed with it, so I don't know the surface quality or the mechanical properties of it, but it's a benchmark, you know. If someone already creates something, it means that there's a way, and yeah, if there's a way, maybe that will also push for other companies to create their own resins, like plant-based resin. Regarding FDM, that's a technology that we don't focus on. You have several. Filament is way easier to produce because filament comes from traditional plastic, and we have a lot of recycled PET, recycled polyethylene. So that, I would say FDM would be the most recyclable of all regarding materials. And also we have companies such as Recycling Republic, that they do have like a circular business model where you buy their filaments that are made out of recycled parts that were printed or recycled plastic in general, and you print your things, and either if you have overproduction, if you have failed parts, or if you don't want to use that product anymore, you could potentially return it to them, and they would be in charge of, they would take care of recycling it and making new filament out of it.
Amazing concept.
It's very, very cool concept.
And it's working. It's not just a concept, actually. It's actually working.
It seems like it's working, and it's not a new business model. It's a very old one, and it's well spread. But it also needs more networking, and that's something that maybe we touch on that later. But that's something that I think it's missing in the industry in general. But that will be regarding FDM, and then if we move to SLS, that we do develop that technology, it's also quite sustainable materials-wise, because, for example, we now have 3 nylon powders. We have nylon 12, nylon 11, and nylon 12 glass filled. And now 4. We also have nylon 11 carbon fiber and carbon filled. And all of these, since it's sintering, it's SLS, you can reuse the powder. All of it if you want to. So that provides the opportunity of having a production with no waste of material, which is amazing.
You can recycle it. That's perfect, And with the nitrogen, right? It's much easier to recycle all of the powder.
With our new Fuse 1 Plus with nitrogen, you can recycle, like, even faster turnover of recycling material can be in the printer, like back in the printer again, and print with that, with the same mechanical properties and with the same surface finish, which is amazing.
How does the nitrogen actually, because when I left Formlabs, there was the Fuse 1, and they didn't use the nitrogen yet. So how does the nitrogen actually work with the printer? Do you know how that works? No.
I know that the machine has been changed, hardware and software. So something that we've been asked is that if you could attach nitrogen to the Fuse 1, and that's no. The Fuse 1 Plus has everything that's needed to be able to print with nitrogen. What I do know is that what we use is a nitrogen generator that you can plug into the printer, and it creates an oxygen-free space where the print is happening, and therefore there's no oxidation when printing. and therefore the mechanical properties increase immensely. But
it's
yeah,
just a more enclosed space with the nitrogen, right?
yeah. The goal is to take all oxygen from the printing space, so no oxidation happens when each layer is created.
Yeah.
Yeah, but I only know like the basics of it.
So, what is your biggest takeaway from all your research about sustainability that you've done at Formlabs at the moment?
Well, I think let's go from sustainability in general, not only for 3D printing, just as an asset for production. I think technology is already out there. We've already developed everything that needs to be done to be able to run a more sustainable production. We just have to allocate this technology to the right places.
Okay. Yeah.
For example, there's already recycled materials.
Yeah.
There are already materials that have a lower environmental impact that are developed, and that they are virgin materials, because I also understand that sometimes production needs virgin material depending on the application. So I also understand that way. There's already
You said virgin
material, like
okay,
material.
So the original OT.
Yeah, material that hasn't been injected, hasn't been used,
okay.
hasn't been changed. It just has been like the first material that you produce. That's called like virgin material, and once you change its form, usually it's pellets or like a big flake of material, and you change it into a chair, or you inject it, thermoform it. That's already used material because heat usually has already been applied, and the quality of the material when recycled is a bit lower. So I also understand that's a challenge for certain industries, but either way, the technology is already developed.
Okay. Well, that's a good point. I think if everything is there already.
Yes.
Then
we also have, for example, if I have to touch on packaging solutions, we have more than enough packaging solutions made out of paper that it's already more sustainable, or recycled paper, recycled cardboard, or even materials that come from wheat or like plant-based fibers that do create a simul plastic, but they are plant-based, and some of them they are even compostable. So we already have enough materials to go back and replace these traditional plastics made out like from petrol-based to a bio-based material that could sometimes be compostable. And so my big one as a sustainability expert, I don't like the word expert because I'm not at it, but I think that
you have more research than other people have done. So
my personal opinion, let's leave it as a personal opinion, is that technology is already there. It's out there, and we just have to allocate it and have the means and the interest in people, and that's where we come in, maybe as a new generation with new ideas, or how to convince our superiors or even the government, because this is a triqueta of things. Like you need people, you need government with their laws, but you also need companies pushing for it. So that would be like my personal aspect. And regarding my research is that materials development keeps advancing and keeps putting the entire world in awe. Creating a new material that it's lighter than air, like the aerogel material, or materials that are compostable, but then you can use it again in your own house. Crazy stuff that you only see in sci-fi movies, but sci-fi is already the present in some cases.
Yeah, I saw just the other day. I saw like an article about an Israeli. A researcher team, I think they built a 3D printer that has like a mixture of soil and some grains and plants that actually forms like a good root structure in that piece, in that 3D printed structure. And that root structure actually allows it to be like a building material.
Oh, cool.
For houses. I mean, they're still experimenting in it, but
yes.
they've also, like, on the facade you can grow your own carrots.
Wow, interesting. Yes.
Or radieschen. What is radieschen in English?
Like vegetables in general. Yes.
Vegetables in general, yeah. That's super
yes.
cool. Like.
Yes.
I wish we could just apply it to, our life already.
Yeah, exactly.
Yeah.
We need more funding maybe to make this technology available for everyone, or maybe we also need a company that establishes a benchmark. That's also a possibility. Something you made me remember with the Israeli company. There's also an Israeli company that they are producing 3D printed fake meat steaks. And there is actually a restaurant here in Berlin, like 1 or 2 Michelin star restaurant where you can have you can have your steak 3D printed.
Oof.
Which is also like tackling another issue that it's meat consumed, and all that also applies to like how we treat animals, how and all that area of food consumption. That it's also a problem that it's not going to go away. We need to eat. So, and we are even more and more people who need to eat. So the food consumption is also an interesting subject. And
that's super interesting. How do they, like how, I wish I could see that steak printed.
I could eat it. Yeah?
Yeah.
Maybe that's for the next video.
That's for the next video. We'll go to that Michelin star restaurant and test that meat for you.
Yeah, but it's something like very cool to show that you don't need to kill a cow or an animal, waste a lot of its parts to produce one steak. You can just 3D print it and you don't need to
You don't actually use meat. But is it meat that they use? Or
it's fake, it's fake meat.
Okay.
So, I don't know the components. So, yes, regarding 3D printing, I think materials development is key. The technology is already evolving, and that comes like organically with new chips being developed, more stronger lasers. That's already like the concept is already done. But materials development is key, and that's what will establish maybe the next benchmark of what a 3D printing company should offer, either like recycling fabric, a circular system where you can return your samples, your parts, and they create new filament out of it, or we'll see. I don't know.
Well, that brings us to another subject, right? To the whole end of use topic. Like, what happens actually after you've printed something? What happens to that part if you don't actually use it, right? Does it, you don't just want to put it in the trash? And there are different technologies that are used for 3D printing, different materials, and each one has their own individual chemical polymer chains. And how do you destroy them, and how do you actually use them again?
Well, that's a very interesting question, because I think that no company has tackled it yet, so that's a big question mark. If we go to the theory of it, FDM is the more sustainable one because it works with thermoplastic polymers, which means plastics that you can heat up. They will change their form from solid to liquid, slimy type of consistency. And then they harden. As they cool down, they harden, and you use that as a product. But then this material can be heated up again and they will melt. Whereas in SLA it's a bit harder because the polymers are thermoset, meaning once the laser hits them and makes these chains stronger, you cannot delete them, you cannot separate them. and that's like a chemical answer, so it's not something that you can change. And that's also the quality of the thermoset. Like if you see an SLA print, it has isotropic qualities, whereas FDM has anisotropic qualities, meaning isotropic is that in all directions, if you grab a part in every single, well, this is a
Not
SLA.
What do we have here? I found something.
Exactly. Thank you. So this sample will have the same mechanical properties in all directions, whereas FDM, since it's only heated up, the connections are not as strong, and therefore if you have the layers in this direction, you can bend it like this and that's going to be fine, but if you bend it like this, the layers will separate when applied enough force. So that's something very valuable of SLA, and thermoset materials that they also help to build that. And so yes, and with SLS I would say that it's vital that you recycle the powder that you can use. I think SLS, that question is already a little bit answered, because also the powders, for example, we have 4 type of nylons, they are thermoplastic, so you could potentially, in theory, recycle them, grind them, make them powder again. But that's all in theory, and
so there is no company that could recycle SLS printed parts?
not. There are companies that could potentially do it. There are, but as I said, networking is vital here to say, if I'm one company that 3D prints things, that I connect with you, that you have a recycling company, or maybe you even produce the material, and we work together to say, hey, how can we close the circle, and make this material reused, or make it go back to cradle. So, to cradle? Yeah, right.
Cradle to cradle?
Like make it go back to the beginning.
So circular.
And make it a recycled virgin material again.
So basically, to have a good network in place is another key factor in being more sustainable.
Yes, totally.
To have
working
producers
together
and recyclers work together.
Yes.
And
manufacturers together with companies that add value because they buy this raw material and they build something together with the recyclers. But it also goes together with government dispositions. For example, in Germany, that we have the fund system. This is a government law that is, okay, the bottles that look like this, this and that, made out of this and this type of glass, can be put into this machine, and every company that is producing a new drink, they can decide if they want to be part of this fund system or not. And that also adds value, and the people, the normal common user, everyday user, they are starting to choose a drink that has or is involved in the fund system because they can return this bottle and get some money for it, than a bottle that may look more like nicer or more tailored, but doesn't go into the fund system. It will just go to the normal glass trash. And that's also something to bear in mind if you want to produce something for your customers. You have to also listen to what they want.
So, talking about end users already, what can an end user do to maybe produce less waste, be more sustainable in their approach of using 3D printing?
There are different design strategies that you can apply. It really depends on what you are focusing on. If you're more of a trader, that you get all the parts and then you assemble them, there are other strategies that you can apply. If you're your own designer, or you have designers in your company, something that is vital is to apply the technology, that to already know which technology you're going to use to build your end-use product. If it's a casing and you know that you're going to use 3D printing, it would also be super useful to know which machine, to also know how to adapt this product with small design changes to be able to print it, and to print it easier, without supports if it's SLA, or faster. So that's something vital to do when applying. Let's talk only about 3D print, designing for 3D printing. That's something vital. Something very good, on the other hand, is that you don't have to think about draft angles as you would need to with thermoforming or injection molding. But it is...
Draft angles? What do you mean by that?
Draft angles would be when you have a mold and you want to open this mold, all the angles that are here should be like in a positive angle, like more open, to be able to take this part out of the mold. If you have something that has a negative angle, it will get stuck in the mold.
Okay. I'm not sure about the positive and negative.
I can bring a model next time. A mold to see that.
Yeah.
Or we can find a sample here maybe.
You mean like extruded and...
Yeah, for example, if you want to... Do you have one without the support?
Yeah.
Yeah. If you want to 3D print this, you don't have to think about draft angles. But if you want to, let's say, plastic inject this one, you need the dividing line of both molds should go around here, because this is the draft angle.
Okay, yeah.
So when you open it, you can actually get it out.
Yeah.
But let's say that this one has like a enclosure or some sort of like weight here, it will get stuck.
Okay.
So you wouldn't be able to make the middle line here.
Okay.
Because it won't come out.
Yeah. Makes sense. Cool.
Yeah. We can also like make a video of like my hands only, like showing that. Yeah. What were we talking about?
Draft angles,
The draft
injection
angle.
mold.
No, how to design for 3D printing. Yeah. So yes, as I was saying, like designing for 3D printing, you also have some. We provide a design guide, for example, with tips and tricks on how to design a part to better print it and to successfully print it, and maybe even print it directly on the build platform. And now that we've developed the build platform too, we have products that are being printed straight on the build platform with no supports at all. And you just bend the build platform and they pop out. And that's your yes, that's your end product. You don't need supports, and therefore you have no waste.
Yeah, that's always the I know you called it like Ordena, our other colleague. She called it like an art work if you didn't apply that many supports, or the right amount of supports, if you didn't over produce and
you
overuse too much material, right?
Yes, exactly.
So you can see it. See it here. You have these support structures, but I could probably reduce some of these support structures if I'm a bit more careful the way I attach them, and then you still get a good print result.
Yes.
Yeah.
This is also a game between the time that you want to allocate to designing this part and the time that you want to allocate to actually producing it.
Yeah.
Maybe you just want to produce 10 or a very small amount of them, and you're not going to spend hours and weeks designing a part. Maybe you allocate this money to just producing them, and then you have someone post-processing them.
Yeah.
Or you want to produce a larger amount and you say, okay, let's make the design as perfect for 3D printing as possible. So then you just produce them and the production runs fast and smooth.
Yeah. Yeah, all very important points to consider, right?
Yes.
If you want to design something, how much time do you have on your hands?
Mm-hmm.
Can you actually focus on designing something so particularly for a long time to actually, consider the material waste as well?
Yeah. Well, something that I think I can mention is for a marketing campaign last month, there was a Women in Additive Manufacturing lunch, and we were in charge of giving away a small gift to every woman. 100 women met to talk about 3D printing. They all work in different areas in the 3D printing industry, and we were in charge of doing that, so we needed 100 of something. So together with marketing, we developed, I designed a candle holder. That of course has to have the Formlabs brand, like the marketing aspect, but also if you want to print 100 in less than a week, you do need to have a little bit more of experience with mass producing samples. So we use the Form 3L and one of our standard resins that prints the fastest, but with very good surface quality. And things that I had to bear in mind was, okay, I want to print straight on the build platform because this is a lot of material. I don't want to have a lot of waste. So I should bring it next time. So I designed a small candle holder and also the measurements that they not only have to be fit for a small tea light candle, but also to be able to fit as many as possible in a build platform. So thanks to designing, thinking about this, and together with our software with Preform, and seeing, okay, a little bit, if I do it 2 millimeters smaller, it doesn't change the design, but I can fit more. I could end up fitting 15 in one Form 3L build platform and print them in 6 hours. All this build platform. And in 6 days of production, we could get all of them out, and the event was successful.
Super
so,
cool.
But that's something that it's worth mentioning and bearing in mind, because you only use the material. I think we printed 102, and we only used the material for those 102, and then we just had 2 left that I have one on my desk. So no overproduction, and you make customers happy, basically.
Super good.
Yeah.
So basically your experience of using the printers helped a lot in designing, obviously, those candle holders. So how did you, more specifically, how did you design it? Did you design it and then print it, or did you check in Preform? That's the slicing software for the 3D printer.
The design.
How did you go about it?
The concept was, let's choose something, okay, what can be nice to have and kind of small but also useful, because we don't want to give just a small statue. I wanted to give something useful, so it was okay, a candle holder. Just a little bit of background information. The candle industry in Germany is quite big. People buy a lot of candles, so that's something that is believed.
It's a little bit cozy.
Yeah, maybe for winter. So we decided on the candle holder. We decided on the resin, and I started designing it. Basically, I started with the size of a candle, a tea light candle. And I was okay, let's see what's already in the market, something small but also cute. And I came up with a design. This is all software until now. I use the Onshape software, that there's a free version but also a paid version, and it's quite good. And it's also and it's a website, so I find that amazing. I'm more of a SolidWorks person and Rhino, but you do need the physical computer to be able to support these softwares. Whereas Onshape, you just enter your account anywhere you are.
Yeah.
And that gives you even more flexibility to work from whenever you are. Wherever you are, sorry. And I designed it there. I checked the measurements, and then I printed one in our draft resin that lasted, I would say, 35 minutes or 40 to print a small model. I checked the lettering, that it was like readable, that you could read the Formlabs, you could see the small butterfly, and I checked it how it looked with a small tea light candle, and then I started production. Yeah,
cool.
Yeah, I think I only had to do one small change, and that was it. Basically, it was a short project. We had enough time to do it, but it was also a challenge for us of saying, okay, 100, the number can be a bit scary when you're not used. Usually we print custom samples, we print them once, so we don't run full production.
Yeah.
So this was one of the first ones that we had to do. And it was like a challenge for us. Okay, how fast can we do it and actually validate what we preach, basically? Like, hey, yeah, we've been able to do this, so it is possible.
Yeah. Well, it's wonderful to hear all these different opportunities you can have at the company as well, and to kind of hone your design skills when it comes to, changing maybe some like minimal measurements.
Yes.
But it does change then the outcome of how much material you're using, how quickly you can produce those parts. So it's really, really important to always check back with slicing software like Preform and I always use it as well now to see. I used it before as well, but always when I design something to see if it makes sense.
Yes, this is something
how much
that
material you're using, and
yeah, exactly. This is something that I was taught in university actually. Our technology professor was very into the production, so we're not a designer that can only like draw something beautiful and that's it, but also, okay, we're gonna design a stand. This stand is gonna be made out of thermoforming. So you actually design also for the technology, and you also have that in the back of your mind without closing your ideation progress, basically, and process.
Yeah.
So you
before you actually decide on the manufacturing tool, right?
Yes, you should also like bear in mind, like, okay, I'm not gonna do something that it's impossible to produce or it's very expensive. You should already like bear that into consideration, and that's something that has helped me a lot to make my ideas come to reality. Yeah.
Super cool. Well, thank you so much for the interview. It's been a pleasure. Is there anything else you would like to add as a final sentence?
I think maybe for your users would be useful to know that if you want to launch your own brand, and if you want to or produce something, it's useful to bear in mind, okay, do I want it to be a sustainable product? Do I want it to be as cheap as possible? To know a little bit where do you want to aim it at, and use the design strategies for that. For example, if you want to design for circularity, start like from the beginning. Okay, if it's for circularity, it has to be a material that we can, for example, if I'm going to do a skincare liquid, maybe the bottle can be in the fan system. So it's like I have my micellar water that can already be put, it looks like a beer bottle basically, but it's there, and therefore this same bottle can go into the fan system and you just return it in any supermarket. So it's a little bit of research that needs to be made, but then it pays out because people really pay attention to it. And at least in Germany, the bio market is getting bigger and bigger. People are more looking towards those things and actually saying, I don't want a plastic container. Or, oh, this is plastic, but this is recycled plastic. Or, this is plastic, but I can actually give it back. So I think that's important to bear in mind.
Yeah. Well, it's been a pleasure.
Yeah.
It was very informative. Very informative, and I hope you could take something with you on from all these information and get inspired to include more sustainability aspects into 3D printing and your product, obviously. Yes, thank you so much, Nadine, for coming here.
Thank you, and you for listening.
Yeah, and if you're more interested to hear more about 3D printing, and of course my topic is always jewelry, but if you're interested to hear more about it, come back to my channel, come here and enjoy more of those topics, and I might have some more interviews with Nadine as well about sustainability. And thanks so much.
Yeah, it will be nice to keep talking about it and like even brainstorming of what can be done. I'm pretty sure there are more ideas out there that I'm not aware of.
Yeah, for sure.
And even like if I may, in jewelry, I've seen a lot of companies also use recycled gold, and like for the Verlobungsring, you can choose your ring to be made out of recycled gold, and that's also an interesting factor.
Yeah.
Because of course jewelry, a lot of people like jewelry, but you can also do it in a more sustainable way.
Yeah, you can produce it. I mean, there's so many companies now also in Germany, and so many things that have place that are in Pforzheim. That's like the jewelry center in Germany where you can get your model printed as well with recycled gold and all those lovely materials. Okay, thank you so much.
Thank you.